Welcome to a lesson with Dr. Powell. Let's take a look at how we can compute the area in a region defined between some curves. Well, first we should know where the curves intersect. Um, Maybe with x values, if we're going to be integrating with respect to x. We can also do something with respect to y, and then we'd need to know what the intersection points are in terms of y values. But for here, let's do x. So these two curves actually intersect at x equals 2. That can be found in a variety of different ways, um, setting these equal to each other and solving. Um, Namely, sometimes in college algebra, you have different ways of thinking about the factoring of polynomials by trying different things out with synthetic division. In fact, start by looking at factors of this and just trying them out. And 2 is a nice factor of that. That's common here. But in this particular case, that's maybe the method that would be used. In other problems, maybe it would be simpler, maybe a quadratic equation or something else to solve. Okay, so now we get our intersection points. Now, how do we find the area? Well, let's kind of look through our region and think about rectangles, like a rectangle that goes up and down right here throughout our region. Now, let's just kind of look at each one of these, as we would have like an a Riemann sum. You notice for a Riemann sum and an integral, the two things are the same. You have width times a height, basically, but you think of this as being like an infinitely thin rectangle, but really it's the same basic setup. We need a height and a dx. So basically we're just looking for the height of our rectangles. What's the height? Well, the y value at the bottom of the rectangle is at a particular x value would be x cubed, because we're on the curve y equals x cubed, and the y value right here would be x squared plus 4. So we take this one and subtract that one off, and then we end up getting the height. We put that height in here with the dx, and we have our integral to compute area. So then we just go through the normal process of integration, and we arrive at an area of 20 thirds. Thanks for watching.